Quantum entanglement is a phenomenon in which two particles become entangled and share a connection such that changes to one particle instantaneously affect the other particle, regardless of the distance between them. This phenomenon has been extensively studied in the field of quantum mechanics and has been demonstrated experimentally in numerous laboratory experiments. In the context of superluminal communication with UAPs, some researchers have proposed the idea of using quantum entanglement to transmit information faster than the speed of light. The idea is that if two particles were entangled and separated by a large distance, any change made to one particle would be instantly reflected in the other particle, allowing for instantaneous communication between the two particles. The basic idea is that a sender could create a pair of entangled particles, and then separate them, sending one to a receiver on a distant planet or spacecraft, while keeping the other with themselves. The sender could then manipulate their own particle in a way that would be reflected in the particle held by the receiver, effectively transmitting information faster than the speed of light. While the concept of using quantum entanglement for superluminal communication is intriguing, it is important to note that there are significant practical challenges to implementing such a system. One major challenge is that entangled particles are highly sensitive to interference, and any external factors that disrupt the entangled state could cause the communication to fail. Another challenge is that the information that can be transmitted using quantum entanglement is currently limited. While changes made to one particle are instantly reflected in the other particle, this does not allow for the transmission of arbitrary information. The relationship between the two particles is probabilistic, and the information that can be transmitted is limited to correlations between the two particles. Despite these challenges, some researchers continue to explore the potential of using quantum entanglement for superluminal communication with UAPs. However, it is important to maintain a critical and evidence-based approach to the study of UAPs and the possibility of communicating with extraterrestrial intelligence, and to recognize that the feasibility of such communication using current scientific understanding remains highly speculative.